So we are going to study the chapter electrochemistry. So the basic definition of electrochemistry is that it is a branch of science which deals with production of electricity from energy released during a spontaneous chemical reaction, and it is also the use of electrical energy to bring a non-spontaneous chemical transformation. So this is the basic definition of electrochemistry. So electrochemistry basically deals with the concept of transformation of electrical energy to chemical energy, or it's vice versa. So this is basic definition and simplest definition. So in electrochemistry we study the transformation of electrical energy to chemical energy. Basically in chemical energy, what we are saying that we are passing electricity to have a reaction which is non-spontaneous. And in terms of production of chemical energy, what we are saying that if a reaction occurs, then it releases some energy, then we want to change that energy to electrical form. So this is basic definition of electrochemistry. Now moving to more aspects. So in electrochemistry, in our syllabus, we generally study redox reaction in electrochemistry. There could be more reaction in electrochemistry, but in our syllabus, what we generally study only those reactions which are spontaneous reaction to change that chemical energy into electrical energy. Moving to next concept, that is conductor. First we have to understand what is conductor. So it is basic term. It means materials which allows a large flow of electricity or current, electric current. So what's new here? In our syllabus, we have to understand that we have divided conductor into two basic classification. First is metallic conductor, second is electrolytic conductors, and sometimes we call them as electrolyte. So we have two types of conductor. First is metallic conductor and second is electrolytic conductor or electrolytes. So metallic conductor are, I'm using example here. The examples of metallic conductor is copper wire, iron, etc. And example of electrolytic conductor are acids, bases and salts. These three, acid, bases and salts, are common example. Any acid any base or any salt. All three will be electrolytic conductors. Now moving to next concept, that is classification of electrolyte. First of all, before moving to classification of electrolyte, we have to understand the basic difference of metallic conduction and electrolytic conduction. Metallic conduction, this is important, and second is electrolytic conduction. Electrolytic conduction. So the basic concept of metallic conduction is flow of electron, while in case of electrolytic conduction there is no electron movement. In electrolytic conduction we have ion movement. So I am writing in short, it is basically due to ion movement, cation or anion. Now in metallic conduction, what we see, there is no change of matter, change in matter. What does it mean? We are saying that in case of ions, we will see that copper 2 plus will gain 2 electrons and can form copper solid. Copper can be deposited. So sometimes we see that in electrolytic conduction we have change of matter, change of mass, something. So in metallic conduction I am writing no change in matter. Here change in matter occur, matter, mass, which can happen. Now moving to next important point in metallic conduction. In metallic conduction, what will we see? It decreases conductivity is inversely related to temperature. This is very important. In metallic conductivity, if I raise temperature, then the conductivity in metals will decrease. So it is just because of this effect I am drawing here. If I have two metallic wires, first is at temperature 20 degrees Celsius, second is at 80 degrees Celsius. So what will happen? We will see that one electron moves to some extent, then moves, it goes like this and comes out of the wire. But at higher temperature, what will you see? These electrons basically collide with one another, so the path will decrease. The mean path, it is in physics portion, the mean path will decrease and will take lot of time to come out of this wire. So that's why we say that the conductivity decreases in metal at higher temperature. But in case of electrolyte, conductivity is basically directly related. So how? So I am explaining. Conductivity is temperature and conductivity is directly related. So it is due to the concept of interionic interaction. If I have Cl negative Na plus, and what will we see? We will see that they have some kind of interaction in between the ions. These interactions are known as interionic interaction. Interionic interaction. So what happens when we raise this temperature? These interaction decreases. What happens? These interaction decreases. Interionic interaction decreases at higher temperature with increase of temperature. Because of movement of ion, it will try to move more, so this interaction decreases due to movement of ions. So this is very basic. So what we have studied in metallic conduction, it is a flow of electron. Next, what I have written in electrolytic conduction, ion movement. In metallic conduction, no change in matter. And in electrolytic conduction, change in matter. So these are the basic points which differentiate metallic conduction and electrolytic conduction. Now we are going to study the types of electrolyte. So we have just uh, seen that in electrolytic conduction we have ion movement. So in types of electrolyte, what will we see? We will see how some material produces ion, how some material produces more ions. So this will be just because of its classification, that is types of electrolytes. So in types of electrolyte, we will see two types of electrolyte. First is strong electrolyte. We are not going to cover it in depth, but we are going to study to that extent so that we will not feel that we have not done. So next is weak electrolyte. In strong electrolyte, the basic definition is in solution, in aqueous solution, they dissociate, ions dissociate completely. Ion dissociates completely. So what does it mean? It means if I have NaCl in the solution with water, then this solution will contain only Na plus, Cl negative ion and water also. But in terms of ions, I am writing only two types, two entities, that is Na plus and Cl negative, because we will not able to get NaCl because it is ionized completely. It dissociates completely, or we can say that ionized completely. Now moving to weak electrolyte, they do not ionizes completely, and ionizes they do not ionizes completely. And here we use concept of extent of ionization, which we termed as the degree of ionization. Here we study the concept of degree of ionization. So I'm writing, now I'm moving to understand some example. So example of strong electrolyte is NaCl, basically salt, some salt, I'm writing salt of strong base plus strong acid, then we will get strong electrolyte. And sulfuric acid is also strong electrolyte, nitric acid is also strong electrolyte, etc. Base include NaOH. Now moving to example of weak electrolyte, we have NH4OH, we have acetic acid, we have magnesium hydroxide. In these example, we have salt of strong acid, weak base, or strong base plus weak acid, etc. So these are the examples of strong electrolyte and weak electrolyte. Now in next part we will study the factors which affects the electrical conductivity. In this we will going to discuss 5 major factors which decide the conductivity of electrolytic solution. So it will going to be very important, and after that we will study Ohm's law, resistance, resistivity, the basic term which we will be using in coming chapter. So thank you so much.